The topic of this worksheet is going to be solving systems of linear equations by the addition method. You will also see this called the elimination method. It completely depends on the book. So if you see somebody talking about solving systems of equations and they mention addition or elimination, it's the same process. Okay, so let's remind ourselves of a couple of really important facts. First, a system of linear equations is a set of two or more linear equations that are solved simultaneously. And that leads us to the solution, which the solution to a linear equation is an ordered pair that satisfies both equations. And what we have found out, especially when we learned how to do this by graphing, is that when we graph these two equations on the same Cartesian plane, we're looking for the ordered pair that satisfies both equations, which just so happens to be that point of intersection. Okay. And we have looked at solving these by graphing, which is really helpful, especially if you use Desmos or a graphing calculator. By hand, it's a little riskier. But then we also learned a method where you can solve systems by hand, and that method was called substitution. This method, addition or elimination, this is another algebraic method where we work things out by hand. So I'm going to kind of explain the method first, and then it may not make sense until you actually see what we're doing, and then hopefully it'll click a little better for you. So in this method, it involves converting the system to one equation by eliminating one variable when adding the two equations. So essentially, we're forcing a situation to occur that when we add the two equations, one of the variables cancels out. Okay, you basically add and get zero. And so that gives you an equation that has one variable that you can then solve for. Okay, so here are the steps. Now, sometimes the steps don't make sense till you see it happen, so just kind of bear with me. If necessary, you may have to solve your two equations or arrange your two equations so that they're in standard form. So if necessary, write both equations in standard form. And please remember that is ax plus by equals c. Now, once you have both equations in standard form, you need to multiply one or both equations by a non-zero constant so that the coefficients of one variable are opposites. Now, we know that variables cancel when you add them and they become zero. So what we're going to do is we're forcing the coefficients of one variable to be opposites so that when we add the two equations, that variable just cancels out. It just, when you add them, it just becomes a zero. Okay. Once you do that, you add the two equations and then you solve for the remaining variable, and then you do some back substitution, plug that variable into one of the original equations and solve, check your answer, write it as an ordered pair. Okay. So let's look at this. It'll make more sense when you see it, I think. All right, so example one says solve each system of linear equations using addition, okay? Now again, somebody says elimination, it's the same method. So solve each system using addition, write the answer as an ordered pair. Now what we're looking for is a way to multiply one or both equations so that one variable has coefficients that are opposites of each other. So same number, different signs. So if I look at example A, my system is made up of 2x plus y equals 14. And then 4x minus 7y equals -8. You have the option here. Do you want to try to get rid of x or do you want to try to get rid of y? In both cases, we don't have a ton of work. We'll only have to multiply one of the two equations. So let's say we wanted to get rid of x. We want the coefficients on x to be opposites of each other. Okay, so that would mean I need to find the smallest number that 4 and 2 divide into evenly. That would be 4. So we would have to figure out, okay, the first equation would need some work. What would we multiply 2x by so that we would get the opposite of 4? Well, we'd have to multiply 2x by -2. And then we'd have -4 and 4. We could add, and those two variables would just become 0. The issue is, if I multiply the x term by -2, I also have to multiply the y and the constant. Now let's forget the x's for just a second and pretend we wanted to get rid of the y's. Well, the smallest number that 1 and 7 go into is 7. So what would I have to multiply that positive y by in the first equation so that it is the opposite of -7? Well, the opposite of -7 is just 7. So I would have to multiply that entire first equation by 7. That way, when I add the two equations, the y terms cancel out. They just become 0. Okay? So let's say that we decided to get rid of x. So let's eliminate. Okay, so in order to eliminate the x's, the coefficients need to be, well, you want to look at 2 and 4, and again, find the smallest number that 4 and 2 divide into evenly. That would be 4. So the coefficients need to be 4 and -4. Well, one coefficient is already 4, so we need to make the coefficient of that first x negative 4. So in order to do that, multiply first equation by negative 2. Okay? So I'm going to take the first equation and multiply it by negative 2. So that's going to give me negative 4x plus negative 2y. So negative 2 times positive y is negative 2y. So I'm going to write it as just minus 2y. And then negative 2 times 14 is negative 28. And then the second equation, I'm just going to bring it back down. So I've got 4x minus 7y equals negative 8. So now we want to add the two equations. Okay, and we're just going to add column by column. And notice what happens to the x's. Negative 4x plus 4x is just 0. 0 plus negative 2y minus 7y. Well, when I add there, I just get negative 9y. So negative 9y plus that 0 is just negative 9y. And then on the right-hand side, negative 28 minus 8 is negative 36. So now I have at this point an equation in one variable that I can solve for. So I need to undo the multiplication of negative 9 and y. So I'm going to divide both sides by negative 9. Well, negative 9 divided by itself is 1. 1 times y is y. And then 36 divided by negative 9 is 4. So right now we have an ordered pair, and we know the y coordinate is 4. We now have to find the x coordinate. So all I want to do is take this value for y and plug it into either of those original equations for x. I need to take this value for y and plug it into either of the original equations for y and then solve for x. So let's say we plug it in here. That gives me 2x plus y, which is 4, equals 14. Well, I need to get the 2x alone, so I need to move the 4. So I subtract 4 from both sides. 4 minus 4 is 0. 0 plus 2x is just 2x. And then 14 minus 4 is 10. I need to undo the multiplication of 2 and x, so I divide. 2 divided by 2 is 1. 1 times x is x. 10 divided by 2 is 5. Bless my heart, right? So we finally get that the answer is 5, 4. Now, I just want to remind you quickly how to use Desmos, okay? You've seen this before in a previous video. We're going to remind ourselves of how it works here. And I probably won't do it again in this video, just this one example as a reminder. So let's go to Desmos. Remember, it's desmos.com, D-E-S-M-O-S. Once you go to that website, you just click Open Graphing Calculator. And what's so nice about Desmos is you can just type the equations in as you have them. If you were using your graphing calculator, you'd have to solve for y first, which is no big deal, but it does take time. So let's see, we had 2x plus y equals 14. And then we had 4x minus 7y equals negative 8. Okay, so you can see here pretty clearly the solution. You can see the two lines, and then you can see this point where the two lines intersect. And if we hover or click on that point, it tells us the point of intersection really is 5, 4. So our work is good. I do also want to caution you, use Desmos as a tool, okay? But don't let it do all the math for you. You still need to know how to do the math. Use Desmos more as a way of checking your work, okay? Now for part B, we have the system 5x plus 3y equals negative 2. And then the second equation is negative 3x plus 6y equals 9. Now, we have the opportunity to get rid of x's or we can get rid of y's. It does not matter, okay? In this case, if I wanted to get rid of the x's, I would have to ask myself, what is the smallest number that 5 and 3 go into? Well, that would be 15. So I would have to multiply the top equation and the bottom equation by some number, okay? And that would be fine. We would multiply the 5, the top equation by 3, the bottom equation by 5, no big deal. But let's look at the y's. If I look at the current coefficients of the y's, I've got 3 and 6. So the smallest number 3 and 6 divided into evenly would be 6. So I would want to force my coefficients to be 6 and negative 6. So if I wanted to get rid of the y's, I would only have to multiply the top equation. So for that reason, I think I want to get rid of the y's because I only have to multiply one equation instead of two. So I'm going to take that entire top equation, and I need to get 3 as my current coefficient to equal negative 6. So I would have to multiply 3 by negative 2. So I want to multiply the top equation by negative 2. So that's going to give me negative 10x minus 6y equals 4. And then I'm just going to bring that second equation down. So when I go to add the two equations, well, 6y minus 6y is 0, or negative 6y plus 6y is just 0. Negative 10x minus 3x is negative 13x. Negative 13x plus 0 is just negative 13x. And then 4 plus 9 is 13. I could divide both sides by negative 13. That'll undo the multiplication of x and its coefficient. 13 or negative 13 divided by itself is 1. 1 times x is x. And 13 divided by negative 13 is negative 1. So right now we have, well, let me put it down here. We have an ordered pair and we know the x coordinate is negative 1. So now we need to find the y coordinate. And what we do is we take the value for x, plug it into either of the original equations, and then solve for x, or well, solve for y. So let's say we do the first equation. You could do the second equation. Literally doesn't matter. So I would take 5 times x, which is really negative 1, plus 3 times y is negative 2. Well, 5 times negative 1 is negative 5. Plus 3y equals negative 2. I need to isolate my 3y, so I add 5. Negative 5 plus 5 is 0. 0 plus 3y is 3y. Negative 2 plus 5 is 3. I need to undo the multiplication of 3 and y, so I divide. 3 divided by itself is 1. 1 times y is y. 3 divided by 3 is 1. So there you have your final answer. The solution to this ordered pair is negative 1, 1. That's the point where these two lines intersect. I do want to be really, really clear. You could have, instead of getting rid of the y's to begin with, you could have gotten rid of the x's, okay? And just for the sake of complete clarity, I want to show you how to do that. So make sure you have this written down. Pause the video if you need to. I'm going to go ahead and erase it. And then we're going to do the same exact problem where we get rid of the x's. So let me erase a little bit more. Okay, so let's this time get rid of the x's. Now, the smallest number that 5 and 3 go into evenly is 15. So we need the coefficients on the x's to be 15 and negative 15. For that to happen, I need to multiply the entire first equation by 3. And since 3x is already negative 3x, we can multiply the entire second equation by 5. Sometimes you have to multiply by a negative to get the opposite coefficient thing to happen. But in this case, we just multiply top equation by 3, bottom equation by 5. So let's see, 3 times 5x is 15x. 3 times 3y is 9y. 3 times negative 2 is negative 6. 5 times negative 3x is negative 15x. 5 times 6y is 30y. And 5 times 9 is 45. Okay? So now let's see. When we add the two equations, 15x minus 15x is 0, okay? 9y plus 30y is 39y, so 0 plus 39y is just 39y. Negative 6 plus 45 is positive 39. I need to undo the multiplication of 39 and y. So I divide both sides by 39 on the left. 39 divided by itself is 1. 1 times y is y. And then 39 divided by itself again is 1. We have verified that y is equal to 1. Now let's take this value for y, plug it into either original equation, and solve for x. So it doesn't matter which equation. Let's say for fun this time we plug it into the second equation. So I get negative 3x plus 6y, where y is 1. That all equals 9. So I get negative 3x plus 6 equals 9. I need to get the 3x alone, so I subtract by 6. 6 minus 6 is 0. Negative 3x plus 0 is negative 3x. 9 minus 6 is 3. We undo the multiplication of negative 3 and x. 3's cancel to become 1. 1 times x is x. and 3 divided by -3 is -1. So we have verified this solution. So the power of what I hopefully just made clear to you is that it doesn't matter which variable you try to eliminate, the process is going to look different, but the final answer would be the same, okay? So make sure you understand the difference in the three methods for solving systems. Remember, there's graphing, which is really good to use to check your answer, especially if you use Desmos or a graphing calculator. And then the two algebraic methods are substitution and now addition, or sometimes called elimination.